Hello physics class, it's Mr. Ng and I wanted to make a short video to walk you through your reaction time lab. This is the lab where you were dropping a bunch of rulers to figure out what had a stronger or faster reaction time, your eyes or your ears, and who had the better reaction time between you and your friends. So here by now, you should have a couple of things filled out. You should have the purpose filled out because I wrote that for you. And you should have the background information. Again, I did that for you. You should have a sample problem here, right? Done. If you scroll down, you should have your own procedures. I didn't walk you through this, but you've done enough labs to know what to write here. How did we do the lab? And a short little diagram that includes the tool you'd use to actually measure, in this case, a ruler. Good. So by now, you should have a strong data table, all in meters, right? So if you have it in the form of like say 19 centimeters, just divide that by 100 to get it into meters, 0.19 meters. All right, that's going to be important. Make sure your numbers are in meters. And from here, from this data, of course, you have all your sample data in. From this data, your averages, let's calculate the actual reaction times. If you notice, this is in distance, right? 0.19 meters, that's how long something is. We want the actual times. And the equation, our derived equation, goes like this. T is equal to square root of 2 times delta D divided by acceleration. In this case, it's going to be the acceleration of gravity, which is 9.8 meters a second. So let's plug this in. Let's try to figure out what we have here, right? Our delta D for Joe Schmo is 0.19 meters, 0.19 meters, and our acceleration is the acceleration of gravity, 9.8 meters a second squared. I'm going to use this space, but you should be able to fill it into the sample data. So T is equal to the square root of 2 times 0.19 meters, right? That's our delta D, right? That's our delta D, divided by 9.8 meters a second squared. Notice that the meters cancel out, and it's going to be a square root of a second squared. The square root and the second squared canceled, so I'm just going to end up with seconds. So if I plug this into the calculator, I'm going to try to put this whole thing into parentheses. So I'm going to type in square root, open parentheses, 2 times 0.19 times, not times, divided by 9.8, close parentheses. I'm going to press enter. And you should get a reaction time of 0.1969 seconds. Because I've only been using 2 digits, let's reduce it down to sig figs. So T is equal to 0.20 seconds. What does that mean? It means for Joe Schmo, it takes 0.2 seconds to notice something and react. That's how fast his optic neurons are. Good? Do it 3 times over here for your boxer, meaning you're going to divide this space into 3 and give me answers for each person. After you do that, let's do it again down here. Again, some sample data. And let's do it again for your ears. Notice that for most people, your ears are not as good as your eyes. So again, our derived equation, T is equal to square root of 2 times delta D times acceleration. Or our displacement. In this case, the displacement for Bobby Hill is 0.84 meters. Bobby Hill is not very good at listening. And then our acceleration is again the acceleration of gravity, 9.8 meters a second squared. So we're going to plug in T is equal to the square root of 2 times 0.84 meters divided by 9.8 meters a second squared. Meters will cancel. My T, again, I'm going to plug it in. Square root, open parentheses, 2 times 0.84 divided by 9.8, close parentheses. and I get a really large reaction time of 0.41 seconds. So it takes Bobby Hill like half a second to notice something is happening with his ears. Good. So when you're done with that, do it 3 times over, right? Give me the auditory times for all of your friends. And then finally, I want you to figure out down here what provides the faster reaction times, your eyes, your ears. Provide evidence. Your numbers are going to be great evidence. And then provide reasoning. Why do you think we're better at seeing than hearing? Or if your evidence says otherwise, why do you think we're better at listening than seeing? And maybe you might bring back some of the stuff you learned in biology. Is there a selective advantage to seeing better than hearing better? Or maybe we use our eyes more often, which is why they're much more trained than we use our ears. I'm really looking forward to what you write here. Take some time with it and write well. Thank you very much for watching.